Hi, everyone. I'm here with Dr. Alex Wiedenhoeft, who will answer your questions today about wood identification and illegal logging. Dr. Wiedenhoeft is a research scientist at the Center for Wood Anatomy Research at the at the U.S. Forest Products Laboratory in Madison, Wisconsin. So we will start today talking about, Alex will give us a short introduction on his research and the importance of wood identification and its applications, especially in the context of illegal logging. You are welcome to post your questions on the chat room board, and we will get to as many of them as possible during this hour. Thank you for joining us. So Alex, take it away. Tell us what you do. You're welcome.
Thank you, Catherine. And please do send in those questions because this is a lot more fun if we can make it as much like a dialogue as we can. The interactive nature of this is one of the real advantages of doing this. So, well, thank you for signing in and watching this with us. My name, as she said, I'm Alex Wiedenhoeft. I'm the research botanist at the United States Department of Agriculture's U.S. Forest Service Forest Products Laboratory. And I'm the team leader of one little piece of that laboratory called the Center for Wood Anatomy Research. So my specialty is the structure, the plant anatomical structure of wood and wood properties, wooden materials, and forest products. So I've worked at the Center for Wood Anatomy since I was 18 years old. I was a freshman in college when I began working there. And I often tell this story at the beginning just to give people a sense because sometimes people say to me, what is wood anatomy? I didn't know wood had anatomy. And why would anyone spend their whole life studying it? And why would it possibly be interesting? And the place where I work, this Center for Wood Anatomy Research, has the world's largest research wood collection. So it's like the world's largest scientific collection of wood specimens from trees that have been identified in the field by a field botanist and then cut down. And the best specimens are backed by herbarium vouchers that are well identified and have good botanical material. And when I was an undergrad, I worked as a landscaper on the weekends, and I worked in the genetics department here at the University of Wisconsin-Madison. And I was trying to pay my way through school, and I still had some spare time. And so I got a job at the Forest Products Lab. And the wood collection is this huge room filled with wooden cabinets with little blocks of wood. This is one of the wood specimens from the wood collection. And you can see it's, a little bit smaller than a person's hand. And you walk into this room, and it's quite pretty actually, because the cabinets are wood and lots of wooden artifacts and objects around. But at least back in the 90s when I started working there, it was quiet. And nothing seemed to be going on because a wood collection is fairly stable. Nothing really happens to a specimen of wood. It sits still, and you don't have to feed it, and you don't have to clean its cage, and it's not difficult to really take care of a wood collection compared to other kinds of biological collections, depending. And I looked around, and I compared to the university where I got 18 inches of lab bench space to do my work. I had an office and I had space, and it was quiet. And I thought, this is possibly the dullest place in the universe, because I hadn't yet begun to learn the actual anatomy of wood and learn what good is a wood collection. What do we do with a research wood collection? And one of the things, and it's one of the topics we're going to talk about today and really focus on, is the identification of wood, specifically in a forensic context to prevent illegal logging, or when wood is part of a crime, or even for forensic-like contexts, like if you have a valuable antique. Sometimes, for example, in the United States, an early colonial antique, so an antique from, say, the late 1700s, if it's made in the United States, might be worth 5 or 10 or more times more than that same piece of furniture that was made in Europe at the same time. And so that's not literally a forensic context, but it's a matter of great financial import for the owner of the antique or someone trying to buy it. So there are lots of different ways that this can be relevant. And this wood collection that we have is the scientific foundation for all of our work. It's the underpinning, really, technically, for our wood identification work. Do we have any questions yet?
Yes, actually, we have one. Art asked us, how many of your specimens, if any, are from trees that have gone extinct in the collection?
That's an interesting question. It's difficult to put an exact answer on this. we make a distinction between all-out extinction, where we honestly believe there are just no more individuals of a given species left in the wild anywhere. And then, and I think probably comparatively few, or possibly no documented cases that I know of where we definitely have extinct taxa, but I've never really looked into that. But another issue, and that's in some ways, especially if we're talking about illegal logging, that's critically important, is we talk about locally extirpated. So you look at a species that would have a geographic range, and certain components or populations from the former historic range are now wiped out. And that can become a real issue when you start talking about biodiversity and genetic diversity within a species and the ability for a species to bounce back. So I think it's very likely, although I haven't really checked, we'll be checking actually in the coming months for Sweetenia, for genuine mahogany, because we have a project looking at the wood anatomy and identification of Sweetenia. We'll be looking for representatives in our collection of what are now extirpated populations. So those particular species are not extinct, but some of the populations that we have represented in our collection may be wiped off the map at this point.
Great. We have another question actually from Art as well, and a related question from Sharon that I'll ask you in a moment. Art wants to know whether people are convicted because of evidence from wood forensics, and can you give some examples if it's possible for you to talk about that?
Sure. In the United States justice system, the first major use of any kind of botanical evidence as in a forensic proceeding was the wood identification and wood technological analysis of the ladder used in the Lindbergh kidnapping. So Charles Lindbergh was the famous aviator from the 1930s, and in the early 30s, his toddler-aged son was kidnapped from their home, and I think the only piece, at least the main piece of physical evidence left at the scene of the crime was a homemade wooden ladder to reach the second-story nursery window. And the subsequent forensic analysis of the wood used in that ladder and the kind of wood technological aspects of how that wood was processed was a huge part of finding and catching and ultimately convicting and executing Bruno Hauptmann for the kidnapping of the Lindbergh baby. And so that was a case where botanical forensic evidence, it was the first use in the U.S. system. And then there have been subsequent cases. I've worked on cases involving murder, where wooden implements were used as murder weapons, where wood evidence was used as trace material to link a suspect to a crime scene. And so in many of the same kinds of ways that other forms of physical evidence are used, botanical evidence and wood evidence can be used in proceedings as well.
So related to that, Alex, Sharon asks, is your forensic work mostly focused on the physical traits of the wood, or can you test something like a tree's DNA from a wood sample? So maybe you could talk a little bit about how you identify wood, and then we can demonstrate your xylotron.
Sure. Okay. Well, I'll back up and do the DNA part first. The DNA identification of plants is a very broad and active field around the world. And plant identification by DNA is widely available in many, many laboratories. And people are working very hard all around the world to build data sets to have increasingly more robust ability to identify plants. Wood identification, since it's a product made by the plant, in theory, at least on paper, you would think, oh, that would be really easy. You have this, it's the same DNA that you would have, a given tree has the same DNA in the leaves as it does in the stem in the wood. And so in an ideal world, we just go into the wood, we'd get the DNA out, use the same techniques, use the same data sets, and get an answer. But it turns out that the extraction of high quality DNA or sufficiently high quality DNA from wood is quite problematic. And that limits our ability to use DNA techniques in routine wood identification. So we could do 15 of these chats just about the beginnings of the details of DNA analysis for wood. It's quite a rich area. It's being researched very actively in the United States, and then very strongly in Germany, Australia, Brazil, and I'm sure other places as well. Those are just the places where I happen to have colleagues that I know are active. So the way we identify wood in the traditional sense is based on the constituent cells, the types of cells, their size, shape, their relative arrangement. So for me, a wood identification begins with a block of wood and a sharp knife, like a box cutter, and my trusty hand lens. And so what I will do to begin the wood identification process is, this is a specimen from the collection, and you can kind of see there's this region over here that's already been cut. And then this area is just the rough saw cut. And a rough saw cut is not a good place to try to look, because you really can't see the features. Even a sharp saw is not as sharp as a sharp knife. So what I will do is I will use this knife to cut and produce a well-prepared small area. And then I will look with my hand lens and start to look for specific cellular features. Do I see vessels? If so, it's a hardwood. Do I not see vessels? Then if they're in fact absent, it's a softwood. Are the vessels large or small? What kinds of parenchyma patterns are present? Are the rays large or small, numerous, a few rays? These sorts of characteristics. And we, of course, I'm a scientist and we're nerds. And as a plant anatomist, we love terminology. And so we have books, that are, 5 millimeters thick, just with all the definitions of the terminology. And mostly it's just a way to have a secret code so that normal people can't understand you when you speak. But the idea is to be rigorous in identifying different sizes, shapes, patterns of cells, and then compare those across different woods. And that's why I began our chat here with this discussion of the wood collection. We have the world's largest research wood collection, which means we have the world's largest resource for doing this kind of comparative work, where we have things collected from all around the world, regardless of whether they're commercially important. Some of them are just botanically interesting, so that we have the broadest possible data set for comparison. So what we have with the Xylotron then is a machine that we're working on. My colleague, Dr. John Hermanson, and myself have come up with this device to try to get a machine, to get a computer to do what I would do, or what I would train a person to do at a field level. So with a hand lens. With standard wood identification, it starts with the knife and the lens and looking at cell patterns. But it quickly progresses to making thin sections and looking at this under the light microscope and evaluating characters at that scale. That's where we would make a distinction between a field level or a screening level approach, and then the laboratory approach, or a forensic investigative area. So our objective with the Xylotron then is to do that field screening and take the human component out of that. Because it takes actually quite a long time to develop real technical competence with wood identification in a way that really allows you to make a difference in the real world. I've gone and done trainings for CITES, the Convention on the International Trade in Endangered Species. CITES listed woods in Central America and the United States and Asia, and done other courses on wood identification in Central America, Europe, Asia, and the US. And you can sit down for an intensive week-long session and teach people maybe 15, 20 woods that they're pretty good at the end of a week. And then if you come back and ask them to do the same thing 6 weeks later, unless they've been practicing the whole time, they're, I was going to say almost useless, which is not, that's too harsh. But what it is without practicing regularly, their ability to reliably get a good result drops way off. And so what we're trying to do is take away that human component. So inside the stainless steel tube, we have a scientific grade camera at this end, a very nice scientific grade lens, and then an array of LEDs that are held in a little 3D printed assemblage to illuminate the specimen. So right now, we have that you can see the end of that. You can see the hole in there, and back up in there is where the lens is. I'm just going to plug the LEDs in. And now it's too bright for the camera, but that's what's going to illuminate the surface. And so to operate this, instead of holding the hand lens up to my eye, we're going to hold the device up to the end of the block of wood. And that is the process that we use. You just place it literally physically on the surface to view this. So if we switch over, the output of the device is being shown in this window here. And if we look at this block, this was the block that I cut a few minutes ago. This is the saw cut. And we can't see the structure that we need. If we move over, now the right-hand portion of this image is the cleanly cut portion with my knife. Yeah, thank you, right there. And so that's the actual anatomical detail that we've exposed. And the magnification we get from the Xylotron is very close to the same magnification as I get with my hand lens. So in the field, we would make a cut with a knife to use this, but in a laboratory, and for the purposes of demonstrating this more conveniently, I have the other end of this specimen is polished very nicely so that we reveal that wood anatomical detail with no artifacts, no scratches from a knife and that sort of thing. So to operate the Xylotron, we actually really only have 3 real steps. The first step is that safe, bloodless cutting of the wood specimen. You cannot cut yourself, you can only cut the wood, and it takes some practice and some technique to get good at that. But so we cut the wood and make a clean area like we can see here. This has been polished, but the principle is the same. Then if you can see in the image, there are lots of very fine lines running vertically in the image. Those very fine lines are called rays. They're a specific anatomical structure in wood, and they need to run vertically in the image. If I turn the Xylotron, now you can see those little lines are running at a 45-degree angle. We can't feed this image into the machine. We need to have the rays running vertically. So the training to operate the Xylotron includes cutting the specimen cleanly and then orienting the rays north-south vertically in the image. And then the last step, cleverly enough, is just to press the S key. And by the time we pan back up, we'll already have an answer. And it says the determined genus and species is Lonchocarpus castelloi. And this is, in fact, a specimen of Lonchocarpus. Now, the interesting issue is, please, thank you. The interesting issue, or one of the interesting issues, is that typically wood identification is not accurate to the species level. So we can't separate, generally speaking, we can't separate Lonchocarpus castelloi from this one, which is Lonchocarpus hediosmus, I guess, different species. So we define species on the basis of, typically on the basis of their external characteristics, floral characteristics, foliar characteristics, and those characteristics are not available in a block of wood. We only have the variation that's present here. And the degree of variation in wood is often not specific, is not at the species level the way it is with flowers, fruits, and leaves. So the system actually technically gave us the wrong species. It got the genus correct, but it got the species wrong, in part because this particular identification model hasn't been taught this exact species, and in part because, generally speaking, we don't have the expectation that as a field tool, the Xylotron will be able to make species level distinctions. So that's not one of our performance parameters we're shooting for. We're getting it sometimes, but we're not expecting to have that, because typically in wood anatomy, we don't expect to have that.
Okay, let's turn to a couple of questions. We have a question from Jason that maybe will be informed a bit by what we just saw with the Xylotron. He would like to know what you think about the biggest bottleneck today in stopping illegal logging. Is it with identifying illegal shipments, or is it improving laws related to import of wood?
That's a great question. One of the things that my piece of this whole puzzle is on the wood identification side, because that's what my expertise is. And, you know, they say if all you have is a hammer, everything looks like a nail, right? And so we tend to approach problems from our areas of strength. When in last December, the United Nations Office of Drugs and Crime convened an international working group. They call it an expert group meeting. And they brought together various scientists involved in different kinds of forensic wood science. And they brought in law enforcement and inspections people, and then different representatives of justice departments from throughout the world. And we all met together to talk about different technologies and how these things can be integrated into investigations to prevent and combat illegal logging. And one of the pieces that came back from the law enforcement people was that what they need from us is not the laboratory techniques. I mean, ultimately, yes, sometimes a case will hinge on a DNA analysis or a really detailed light microscopic analysis like we would do in my laboratory. But typically, the bulk of what they need is they need tools in the field in real time that can allow a law enforcement officer to do their job. So we have trained professionals all throughout the world who are very good at investigating different kinds of crime. There's a lot of expertise in the world for how to investigate drug trafficking. And what we're learning is the techniques that are used in drug smuggling are very similar to the techniques that are now being used in timber smuggling. And so people that had built expertise in that one area, in the area of drug law enforcement, are now moving over into timber and wildlife enforcement because their training and their techniques are relevant. And so the biggest bottleneck is probably delivering scientifically meaningful, robust, and rigorous tools to law enforcement in the field in real time to help them, as the one guy put it so succinctly. He said, all I need as a law enforcement officer investigating an illegal logging crime is an excuse to start asking human beings questions, to get people to start having to say, well, yes, it's this species or it's that species. I got it here, I got it there, and to catch them lying. And so I think the biggest bottleneck actually has to do with delivering the information and the knowledge, the technology, the tools to law enforcement to be able to do this work on the ground.
Okay, great. We have a bunch of questions coming in now, Alex. There are a few that are related to the technique of using the xylitron that I'd like to get to, and I'll kind of lump them together. David wants to know if the knife cuts need to be against the grain or if they can be with it. And David Coulter would like to know if the wood can be has to be dried or if it can be green. So perhaps you can address those first.
Sure. Those are both good questions. When wood goes from green to dry, it actually shrinks some. And so there's a small degree to which the fact that all of our scientific reference images are based on dry specimens, some of the metrics that we have will be slightly influenced by that shrinkage that would take place during drying. What we've found so far, we haven't actually actively tested green wood, in part because we're in Madison, Wisconsin, and I don't have access to any freshly cut down Lonchocarpus because it doesn't grow here. But we haven't tested that, but we've found that our system is fairly tolerant to different kinds of artifacts. So being slightly out of focus doesn't actually, it's not a deal breaker. It doesn't completely destroy the efficiency of the system. Having some knife scratches doesn't seem to confuse the system into thinking that's actual wood anatomy. So there's some robustness to tolerate variable, some variations there. So if I had to guess, I would guess that it would probably tolerate looking at green wood fairly well, somewhere between fairly and extremely well in terms of how it would perform. The question about the end grain versus along the grain is a great question. That's something that I skipped over. I should have said. When we talk about wood identification, the bulk of the information that we use to identify wood, with a hand lens at least, is found on the end grain. It's that view that we just showed you through the xylitron, where you can see the vessel's little holes that water flows through, and the other characteristics. If you cut along the grain, you don't get as characteristic an image. And I usually liken this to looking at people's faces. So as a human being, you tend to identify your friends, your acquaintances, your loved ones by their facial features. You probably have a few special people in your life that you really could identify just looking at their hand or something. But most of the people you know, you're going to feel confident in identifying them on the basis of facial features. And the face of the wood for hand lens or macroscopic identification is found on that end grain or the transverse surface. It's an important point to be clear about. Yeah.
Great. A couple other technique questions, and then we'll move on a bit about illegal logging. Sharon and Steve had a couple of questions. One was asking whether there was any chance an identification could be confused if the tree sample came from an unhealthy tree, or do diseases not affect the characteristics you're looking at? And then also about environmental conditions and whether that affects the structure of the wood.
So one of the difficulties of trying to teach a machine to do this is that machines don't have judgment. They just have data. And human beings have judgment. So if I were to teach a wood identification course and you were to attend it after a week, other than wanting to cut your ears off your head and never hear the sound of my voice again, after a week, you would have seen enough wood structure that if you saw something completely crazy looking, you'd say, something's not right about this. I need to prepare a different spot on this specimen, or maybe we need to cut a few inches off of this and look somewhere else. Maybe we're right by a branch and all the cells are pointing the wrong way. The machine's not going to tell you any of that. So we still do need some level of human judgment. There are some kinds of wood defects that we don't allow into the reference data set that we're collecting. So we take a scientifically collected specimen of wood and we prepare it and polish it for collecting research quality images. And then we collect those images, as many as we can from each specimen, to represent as much of the variability that this specimen can give us. Not just one image, but dozens of images to capture as much detail as we can. But if this has been colonized by blue stain fungi and it's not uniformly colored and it has areas that are stained and areas that are unstained, we can't use that specimen because right now we don't have a way, or we haven't figured out a way, I guess, yet to tell the computer, oh, just ignore that, that's fungal staining. I can tell you as a human being that, show you 3 or 4 times, and you'll know it forever, and you'll get it. It'll make sense. But machines don't get things. They have to have rules. And so this issue of disease or not can be an issue depending on the kind of disease. You can have vascular wilt pathogens that can clog up the vessels and make them look in a way that they shouldn't look. That's not representative for the species. And right now, we're in the comparatively early phases of teaching this machine to identify wood, and it's less tolerant of those kinds of things than when we get to the point where instead of having thousands of images or tens of thousands of images, when the machine is operating on a data set based on millions of images, we expect that the ability of the machine to tolerate those kinds of defects will be much greater. But it's a good question. Right now, it's really meant for screening so-called normal wood.
Great, thank you, Alex. Gregory had some questions about illegal logging. How are loggers informed about which species are illegal to harvest, and does the list change a lot? And if there is illegal harvesting, what penalties are there for such logging?
Illegal logging itself is actually a really big area. We tend to, especially in a context where we're talking about wood identification, we tend to focus on species that are protected. But the bulk of illegal logging that's going on is not necessarily harvesting a protected species. It can be something as simple as cutting down any tree on a plot of land that is not yours, or to which you don't have legal right to harvest anything. So you could be harvesting a totally non-endangered, completely appropriately harvestable tree. But if you don't have legal right to do it, that's been illegally logged. So illegal logging is actually a very broad topic. It encompasses lots of, for one, regional variations in law and what different countries or legal entities choose to declare as illegal through their own processes. And that's something that we can't control as an importer nation. And on our side, so we can only address certain aspects of this with wood science. Other aspects of this have to be addressed by boots on the ground police work. But I guess I feel like I'm only answering part of the question. I think I lost a little bit of the thread there.
The penalties and if the list changes, but I think you did catch
the list. The list does change, and that's done on a case by case or country by country basis. In the United States and in Europe, and I believe now in Australia, we've all just passed different, similar but different laws that basically say it is now illegal to bring into the United States any material, any wood material that was harvested in contravention of the laws at the point of origin. So we don't necessarily have laws in the United States saying it's not okay to shoot a rhinoceros and cut off the tusk. right? So we have a law called the Lacey Act. It's also covered by CITES, but we have a law called the Lacey Act that says wildlife harvested in contravention of local law is illegal here as well. And that act was extended to include plants and plant materials, including wood and wood products. And so we have that. The European has the, I think it's called the EUTR, and the Australians just passed something similar. So there are a lot of the major markets of the world are doing something to say, this is how we as importer countries or importer regions can take some responsibility for helping producer nations control their environmental resources and participate in the legal commerce and law enforcement activities to protect what other countries have chosen to protect.
So relatedly, David says that, he recognizes that while the Xylotron is a great tool to help catch and punish criminals once a crime has already been committed, how are authorities trying to change the minds of the local people that these activities are not in their best interest? And what are these boots on the ground? What do you think is another approach? And maybe perhaps that's outside your purview. But.
Yeah, well, I mean, I only know about these things in a casual conversational way with colleagues that have more direct association with the forest, either because they live in countries or regions that are producer regions. There's the social component. There's the scientific component. What can and can't we do? And how can we advance our ability to support law enforcement actions? Then there's the law enforcement component. How can police officers and other regulators go out and catch this after it's happened? And then there's this social component, right? That involves commerce, and involves people's consumer habits, and it involves how people see and value the forest and how they understand it as a resource, and whether they choose to protect it or see value in it. And those get into ethnobotanical issues and sociological issues, legal framework, social justice, real world economics, things that I don't know anything about, for one. But yeah, I mean, they're absolutely central to issues on this. And ultimately, something like the Xylotron or hand lens training or whatever, the closer we can move those technologies and those approaches, the closer to the forest we can get those, the more likely we are to make a difference. So having the Xylotron in Madison, Wisconsin, I mean, this is where we're developing it. So that's we get a free pass, but it's really not that useful in Wisconsin. It's much more useful at a border control or a border crossing in Costa Rica, or along a highway coming out of the Amazon going into the state of Sao Paulo, right? Those are where you can deploy something like this and make a difference. And the closer we can get that to the forest, the more likely we are to choke off the profit associated with this. And that's part of the vision for how to make this effective, is by making it progressively less lucrative to engage in this, because people get caught. That's the hope, at least.
Okay, we have a question from Anna, who wants to know what you think is a better use for wood that is confiscated, other than burning it or storing it indefinitely.
Yeah, that's a tough one. With regard to CITES seizures, anything seized under CITES authority cannot go back into trade, or at least, let me back up. I'm a botanist and not a lawyer. And so when I'm saying something like this about CITES, this is based on my casual understanding of it. This is not an actual, legal edict, because I don't have that expertise in the legal arena. My understanding is that materials seized under CITES authority cannot go back into trade. So they had the large crushing of elephant ivory within the last year or two that made the news. I have a pallet of about, let's see, what is it? It's a little over 3 meters long and about 1.5 meters wide, and about, I don't know, maybe 20 or 30 centimeters tall, of veneers of genuine mahogany out of Brazil. And these are beautiful sliced veneer, not peeled veneer, very high value stuff. It's clear, it's gorgeous, it's amazing. It was a CITES seizure that came into the port of Detroit. And they were going to, yeah, it was in the video, and they were going to destroy it. And they made it available to us because we're a research institution. And so we have it on display as an example of something that even with a simple tool like a hand lens and an identification manual, a place where you can make a difference. The declared value of that pallet was, I think it was $8,950. The actual value, according to a local kind of fine cabinet maker, is somewhere between about $250,000. So that was an example where they were trying to also kind of fudge on the value of it. Now, what happened to it? It got sent to us. If we as a country, not we as a laboratory, but if we as a country were to say, okay, we're going to take CITES seized material and we're going to send it back out and we're going to sell it, and then we'll use that money to support law enforcement or support research. There are people out there that would argue, well, that would be great, right? But I think the counter argument is, when you do that, you're still kind of tacitly feeding the demand, because now you've made this material available and people see it and they say, oh, it's really, really beautiful. And it's available via legal or not so legal means. And so they still go for it. Whereas eventually, if you cut them off cold and they just can't get it no matter what, they will move on to something else. And so that's part of the rationale. So what other things could we do with them? I think in theory, it might be valuable to have a way to store up some of this endangered material, to have it available for historical renovations of important cultural heritage. And I'm not thinking architecture, I'm thinking more like cultural patrimony, especially from cultures that might have been wiped out, like the Taino people of the Greater Antilles. They had a really rich, interesting heritage with wooden cultural patrimony, and as a people, my understanding is that they're gone. But to be able to make some of these woods that they used in their materials, which are CITES controlled, available for restoring artifacts could be valuable. But I don't have an answer to that.
Well, let's move on. A couple of people here that seem to work with wood ask, you mentioned that U.S. is mostly a wood importer. How much of the wood products, such as lumber for building, et cetera, sold here in the U.S. is grown domestically versus imported, and how much of it is checked, whether it's illegal, though that wood imported is illegal or not?
Right. Well, for one, I'm not any kind of forest products economist. So at the Forest Products Laboratory where I work, we have an entire research group of economists who work on these kinds of questions, and they're much better qualified to answer these with real numbers. So I don't have any real numbers to put on this. My understanding is that the bulk of what we bring in for construction tends to be softwood lumber from Canada and softwood lumber from other places that we would typically consider comparatively low risk for likelihood of illegal logging. The place where people think, not we, because it's not really my area of expertise, but where people think we have higher risk for illegal logging have to do with tropical imports, which we bring in for specialty, for things like flooring and paneling, and then more specialty uses or smaller volumes, not in huge volumes like we would for construction. And then another aspect is some of the northern boreal or north temperate materials coming out of say the kind of, let's say, Russian and Asian Far East, Northeast area, where there's species that would be very similar to what we would have in the US or Canada, but where it's pretty widely known to have significant illegal logging. And those are some of the Siberian oaks and some of the softwoods there. And but that's not coming in for construction so much, but for other purposes.
So related to that, we have a furniture maker, Dave, on the line here that wants to know what your thoughts are on how he can ensure that the rough wood he buys is actually not illegally sourced. He uses the word sustainable, which I know the two are different. What would you say to Dave?
Right. It's a great question, and questions like that I think are actually important for, especially in the United States and other consumer nations. There's a degree to which we have to take a little bit of responsibility for our role in this situation, and say, as people who consume this material and see it as a commodity and don't really live with the forests that produce it, maybe it certainly is argued by some people, and I'd have to be inclined to agree that we have a certain degree of responsibility to be a part of the solution on this, and maybe engage in some level of oversight, or at least being conscious of what we're doing. There are various different approaches that people take to assure some kind of legality. There are a variety of different certification schemes that are available out there, that people look at as a way to ensure that things are at least legal, if not some definition of sustainable. As a consumer, one of the things to do is ask questions. In my 20-some years of doing this now, or I guess a little over 20 years, I've found that when I deal with an importer, when I deal with a company through my normal work trying to help wood industry in the United States at the Forest Products Lab, when I ask them a technical question, when I get an answer and the person has no idea what's going on, they don't know the scientific name of the wood that they're using, and they don't know where it was brought in, and they don't know how many board feet, and they don't have answers to these very obvious and simple questions, that's always a red flag for me. When I ask people, say, hey, I'm concerned about, as a consumer, I'm concerned about this being responsibly sourced, whatever that means. And what do you guys do to ensure that as a retailer or as a shop? They should have an answer. If they don't have an answer, or if it sounds like they're winging it, I would call that a red flag. Mm-hmm. So just being an active consumer, asking the questions and seeing if they seem to make sense would be the first step, I would say.
Okay, so for some of these woods that are coming out of, say, the developing world, or areas where there's a higher risk for illegal sourcing, what sort of wood identification procedures do most of those countries have at the moment, and how soon would, say, the Xylotron be available to be implemented in the countries where most of the illegal wood is coming out?
Right. Okay, that's a good question. The state of the art for field wood identification around the world is still the hand lens and the sharp knife, coupled ideally with a locally or regionally relevant wood identification field manual or key or resource that's appropriate to the situation. And that's a point that's worth making. Wood identification, if somebody just hands you a block of wood and says, what is this? That's quite difficult. If someone hands you a block of wood and says, is this red oak? That's a much easier question to answer. So when we control the context of the question, or we know kind of how big of a box we can draw around the question we're trying to ask, or trying to answer, that really empowers us to achieve much better results. So around the world right now, the state of the art, like I said, it's the sharp knife and the hand lens, and then training a human being to get good at this. And the great thing about human beings are that they do have judgment, and that they do have the ability to adapt to different situations. The downside is that they get promoted, they retire, they forget, they don't practice, they get run over by buses. You know, things happen to people, and expertise is lost. And that's actually a very common theme worldwide, is the gradual decline in expertise in wood identification and wood anatomy globally. And it's a problem that's been identified not only by wood anatomists, which would be kind of self-serving to say, hey, there aren't enough of us, but by law enforcement and by other agencies interested in trying to combat illegal logging are starting to say, hey, we need young people or people to go into this to grow these fields. We need to have successional planning so that expertise isn't lost. We need to protect and maintain and grow these research wood collections around the world. So right now, global capacity is not where we would like it to be, but there's a real awareness and a growing and broader awareness of the fact that this is probably a meaningful thing for people to be able to work on and move into to make a difference still.
And how far out are we in the broad deployment of, say, the Xylotron in these other countries that might need it?
So the Xylotron right now is in a pilot phase or a prototype phase in the laboratory, and we're going to be deploying it in the state of São Paulo in Brazil with my colleague Sandra Florsheim. She's spent the last 8 or 9 years training law enforcement, federal military police, federal environmental police, state environmental police in how to go out into the field and cut a wood specimen and look at it with a hand lens, or her system that she pioneered, and it's amazing for its brilliance and how well it works, is she sends them out into the field with a little USB microscope, so kind of like our Xylotron, but much less expensive. And they take an image of the wood at a control point, at a checkpoint along the highway, and then they email it to the laboratory, and the laboratory staff knows that there's a law enforcement action going on, and everybody sits around the table with their laptops, and then they make identifications based on these transverse sections of wood, and they make provisional identifications or screening identifications and tell the police whether or not to seize that shipment or seize that log, and say that looks like it's something that's protected, you need to seize that. And then they cut specimens and send them to the laboratory. It's amazing. It's brilliant. It works so well. That's really a marvelous thing that she's done. And so we're very fortunate to be partnering with her and able to actually send the Xylotron out into the field in Brazil in the hands of the federal police. So we'll get real-time feedback, and they will get real-time feedback. So they already are trained in how to prepare the wood. They'll image it with the Xylotron. The Xylotron will give them an answer based on a Brazilian wood identification model. They'll be able to use that answer in real time, but then also have the human being looking at that image that's been emailed to them, which then we can see if there's congruence between what the machine said and what the human expert said. And then when that specimen comes back to the laboratory, we can confirm all of our results. And that's going to allow us to make it a lot more robust. This is a very long answer to the question, when is this going to be ready? We have right now developed an identification model for commercial Central American timbers and commercial Brazilian timbers. And that's it. One of the dirty little secrets of science is that we really can only get as much done as we have funding to do. And we've received funding predominantly from the U.S. Department of State, and then supported by the U.S. Forest Service, Forest Products Laboratory, and U.S. Forest Service international programs to develop this prototype. So to go from nothing to having a device that does this and having software that makes identifications, and then to develop a model for the commercial woods of Central America, and then subsequent to that to develop this model for commercial Brazilian woods. We're very hopeful about future collaborations with the Forest Products Lab in the Philippines. I have a visiting scientist in my lab right now who's interested in this and taking this technology back and working with their scientifically collected specimens, and a team of colleagues who've petitioned the Ghanaian government for funding to come to our laboratory and build a set of these, image our West African woods, and then go back and image all of theirs to develop a relevant regional African model. So we're in the process of growing this, but we're also in the process of still finishing kind of the play testing and model development and the prototype phase. So it's a work in progress. We don't have a hard date. Other than that, we'll begin field testing in Brazil probably in the next 6 to 9 months.
Great. So we have a question from Dave Coulter. It sounds like you had some buy-in, at least from a number of nations, but the nations that you do work with, are they generally helpful with enforcement, or is there a lot of looking the other way, is what they would like to know?
That's an interesting question. I don't have anything other than anecdotal evidence on this. I know the most about Brazil, I suppose, because of my colleague Sandra, and I've been down there a number of times and worked with her and the law enforcement people down there, at least peripherally. And the people in Sandra's group are extraordinarily committed to this. And the people in law enforcement down there that she's trained for the inspections are some of the most enthusiastic, positive people about the fact that they see themselves as having the ability to make a difference. And I find that really, really encouraging. The downside is that there in the state of Sao Paulo, this wood is being cut up in the Amazon. Trees are already cut down by the time they're coming to them. And so that kind of choke point that far away from the forest is not ideally what we want to see. My understanding is that when we tend to have graft and bribing and these sorts of bribery and these sorts of things supporting the kind of the dark underbelly of illegal logging, that stuff is often happening, not always, but often happening closer to the forest. So where the political clout of a lumber baron is much higher, near the forest, for example.
So that relates a little bit to a couple of questions Gregory has posted of what good is saving a few rare species if the rest of the forest is gone, and how can conservationists and scientists inform law enforcement as to what the priorities are?
Yeah, the interplay between how do I want to put this the right way? When you talk to different scientists with different areas of expertise, they would probably give you a very different endangered species list than, or something like that. Let's say that in quotes, not as an actual specific list, but a different idea of what the priority species should be compared to, one scientist will probably give you one list, another scientist to give you another list, and so on. And we see this in different forms of international adjudication of these issues, where country A says, we want to protect this species. And country B says, well, that's not going to work for us because we have lots of that and we're going to keep harvesting it. So we can't declare the whole species off limits. So you declare that species from your country illegal, fine, but we're going to keep cutting. And when you have that, now you're no longer protecting a species. Now you're talking about protecting different populations, or even worse, you're talking about protecting what's actually one big population with an artificial line through it called a country boundary. And then trying to ask science to deliver some way to separate that. So those kinds of questions, like how do we get the list to be better targeted or more focused or more what we want to see? I don't have any kind of solution for that. I think it's a good question. I think it's something that everybody has to struggle with. Each country has to struggle with it on their own, and come up with what they want to prioritize and how they're going to do it, and which I realize is kind of a cop-out answer. I'm not meaning it that way, but there is no single way to answer this, I think.
Well, there's clear role for wood anatomists, and somebody asks here in the feed, how many wood anatomists are there in the world?
Yeah, so this is going to sound like one of those funny textbooks from Harry Potter, but the scientific organization for wood anatomists is called the International Association of Wood Anatomists. And my understanding is that there are just a little under 500 members worldwide of what we call the IAWA, or International Association of Wood Anatomists. And of those 500, in round numbers, wood anatomists, not all of them are interested in, capable of, or qualified to perform wood identifications. Now, not everyone with some useful forensic expertise in wood identification belongs to IAWA, but if we had to guess, we might say that there are only a few hundred people in the world who are qualified to do this work at a forensic level. Maybe not even a few hundred. I would personally be inclined to put the number probably much lower than that for a forensic level. For a screening level, we probably have fewer than a few thousand people worldwide who have sufficient expertise in a broad context to do wood identification screening. I think you have people who have learned to use the hand lens who work in one region or at one border control area where they have 10 or 20 species that are the only things they have to worry about, have tremendous expertise and are very effective and very accurate. But that same person maybe couldn't work at an international port and make a difference. So capacity is fairly limited. That being said, we seem to get a lot done for there being so few of us in terms of the enforcement side of things.
Okay, great. We've got a few minutes left. Folks, if you still have some questions, go ahead and post them. I would like to know, Alex, do you think this tool will be ready in time to save threatened trees from being exterminated by illegal logging?
Well, yes and no. There are some species that are so close to being extirpated that it's probably a lost cause. I have some colleagues in Central America who are very interested in a specific species of Dalbergia that grows in their country. And so they went to the literature and they went to the range maps and they said, oh, it grows in this coastal area and it grows in this inland region. And they went out and went looking, and all they found were stumps. It wasn't a clear-cut forest. It was selectively logged. This particular species, they found stump after stump across its native range, but no living trees, because people had already gone in and taken them. And for cases like that, we may not have sufficient reference material in scientific collections to develop a calibrated model sufficient to make the identification, and two, it might be too late. And we should also make a distinction. It's probably worth mentioning that there's a difference between biological extinction and commercial extinction. So if all of the trees of a given species are only 10 centimeters in diameter, that's not large enough to harvest. Most tropical woods, and we tend to focus on tropical woods when we talk about illegal logging, we're interested in the dark colored or richly colored wood in the center of the tree, the heartwood, not the lighter colored wood underneath the bark, the sapwood. And so when we harvest these species, we tend to cut off the sapwood and throw it away. So in ebony, for example, you might have a tree that's this big around, and you may only have this much heartwood in the center. So you just cut down a tree this big, but you only have a few inches of at all even remotely usable wood. And that wood in the very center of the tree is the lowest quality wood in the tree. So in fact, you may have cut that tree down and you may get nothing from it, because it's what we value from it, the heartwood, is not there. And so we make a distinction then between things being commercially extinct and being biologically extinct. There are a number of different things that are effectively commercially extinct because either the only remaining commercial size individuals are in protected areas, or because commercial size individuals don't exist, or don't exist readily in places where human beings can log them easily enough.
We've just got a couple minutes left, and I've got a message in from Steve that wants to know if there are other types of identification techniques or processes being worked on for identifying wood.
Absolutely. So we have to make a distinction, and I've tried to separate this a little as we've talked, make a distinction between a field level screening, something you would do at the forest, in the port, at the lumber mill, something like that, and a forensic or a laboratory based setting. In the field, right now, the number one way forward is with the hand lens. Then we have this vision of the xylotron making a real contribution. There have been some efforts to train dogs actually to sniff various high value tropical timbers. So they've had successful mahogany smelling dogs to identify mahogany shipments. There are some of my colleagues in Brazil at a different institution who are working on near infrared spectroscopy for scanning the surface of woods to identify woods. And they've done some really nice work showing the utility of a handheld near infrared spectrometer and scanning to separate mahoganies from some species that look similar with the naked eye down in Brazil. So there's some possibility there. In the laboratory, there's a really rich future. It's complicated and it's not going to be the panacea that everyone wants it to be, but there's a really rich future for DNA-based identification. Laboratory-based machine vision is much more precise than the field-level machine vision. Traditional microscopy, the kind of my core expertise, is still really strong. There are some really interesting work going on using different kinds of analytical chemistry methods, chemotyping, and looking at the different chemicals that make this heartwood darker in color. Can be species specific or genus specific. And so using different kinds of analytical chemistry techniques, you can identify those and make identifications. So there's really a rich body of forensic wood science going on that's not just wood anatomy, not just traditional identification, not just machine vision, that supports these efforts to combat illegal logging.
Great. Well, we're almost out of time. I would like to thank everybody so much for attending these broadcasts, and thank Alex for giving his time for us and this MOOC. Both of the broadcasts will be posted online to be able to watch whenever you would like. There won't be the possibility to post questions, but they are there online at the same YouTube links that we originally sent out, so you can look at them at any time in the future. Thank you so much, Alex, for being here. It's been fun.
Thank you for having me. Thank you for participating.
Bye-bye.
Bye-bye.